Right. We are now recording. So we are covering sections 3.1 and 3.2 today. So we are going to, section 3.1 is looking at measures of central tendency. So all of the different ways that we measure averages and when we use them and what they mean and how we calculate them and everything. Section 3.2, we're going to look at the range, we're going to look at standard deviation, and we're going to spend about 30 seconds looking at variance. And then we're going to talk about the empirical rule. The empirical rule is, in my opinion, one of the most important things we learn. It's pretty easy. It's a pretty easy concept, but we keep referring to it over and over and over again the entire term. So it is a super important thing that we learn in stats. So that's today, and we'll get going. Oh, and we will be using our fancy schmancy calculator today, probably. Yeah, we'll probably be using our fancy schmancy calculator today. Just FYI. If you don't have it with you, that's fine. You can just rewatch it and go along with me later. Okay, 3.1. So we hear the word average all the time. This is a word that is so normal in our language that we probably don't even think about what we mean. We just use it all the time. So there are several different things that are average in stats, and there are 3 different measures of central tendency that we use. One of them I definitely wouldn't call average, but they're all kind of under that average umbrella. So this describes the average of the typical data value. So when we hear the word average, we think of things like average miles per gallon, national average commute to work, average household income, average height of American woman. I don't know if that's really 5'4" though. Seems awfully short for the average height of the American women, but I don't know. But I'm only 5'2", so no matter what, I'm below average. So these are different ways that we hear average in our day-to-day lives. So the arithmetic mean, or just the mean, is the most common average that we use. And I'm sure that all of you have used this. So we just add all of the values together and divide by the number of data values there are, or the number of observations. So we have different symbols we use when referring to mean, whether it's population or sample. So when we're using population, we use this symbol right here. It is called mu. And when I draw mu, it looks something like this. And I'm not the best mu drawer in the world, but that's what my mu looks like. So if you ever see me draw that, that's a mu. It's basically a U with a tail, but mine kind of looks like a fancy squished M, but it's basically just a U with a tail. And this is when we use population. And this is a parameter. It describes a population. So mu is used with population. The sample, when we're referring to a sample, we use this symbol. It's called X bar. Really creative name for that. It's an X with a bar over its top. So X bar is what we use when we're referring to sample data. That sample mean is a statistic. They are calculated exactly the same way. Just one of them has that symbol mu and the other has a symbol X bar. But they're calculated exactly the same way. Is there a question? So we just add all the numbers together and divide by how many numbers we have. That's our calculation, right? Moving on. This symbol right here, that's an uppercase sigma. This is a capital sigma. It just means add them all together. That's all that means. I don't know if you've seen it in previous math classes or elsewhere. I'm sure you've seen it places before. Maybe didn't know what it was. It's also, yeah, so it's capital sigma. And it just means add them all together. So we add all of the values together, divide by how many there are. If you get a decimal, we generally round to one more decimal place than our raw data, or whatever My Open Math tells you to do. They will tell you what to round it to. And so we just kind of follow their lead. But if you were doing this on your own, let's say final project or on the written homework, You round to one more decimal place than your raw data. If it doesn't tell you what to round to, I'm not going to mark you down. If it doesn't tell you round to one place and you round to 2, I don't care. Just let you know, it's not something I'm going to be like, oh my gosh, this should have been 8.1, not 8.11. I don't care. My open math cares more than I do. This is just kind of like rule of thumb. This is just basically what they generally do. All right, moving on. So we're going to actually math it up. Change color because I get bored with one color. So this data represents the travel time in minutes to work for all 7 employees of a startup web development company. So all 7 of these employees, we're going to compute the population mean. So I'm just going to add them together. I guess I could have just written pluses in between all of those. And there are 7 numbers. So if you put all of this into your calculator at one time, make sure to put parentheses around your numerator if you decided to put the whole thing in your calculator at once. Otherwise, it's going to give you a very wrong answer. Right, so I got, let me go back. It's approximately 24.9. So a travel time in minutes. So the average travel time is about 24.9 minutes for all of the employees of the startup company. So this is all the employees. So this is a population. So this would be a mu because it is all of the employees of this startup web development company. So now we're going to take samples. I guess I should erase that before I move on. So now I'm going to take a simple random sample. We're going to do this a couple of times. We're just going to randomly choose 3 people. So your calculator can do this for you. If you have your fancy schmancy calculator with you, if you click on math and arrow over to prob, so click on math and arrow over to prob, the number 8 down there, rand int no repeat. I guess I could show you my web calculator. Rand int no repeat, like this. This is number 8 in that math menu. What this is saying is choose a random integer, but I don't want any repeats. So this, I could tell it to choose 3 random integers and not repeat any of them. So if I click on that, if I want my lower bound was, I'm going to do 1 to 7. My lower is going to be 1. My upper is going to be 7. So if I got a 1, it would be this first one. If I got a 5, it would be this one. And then I want it to choose 3 values. So it'll look like this, 1, 7, 3. Then when I hit enter, it's going to give me 3 values. What it gave me was 7, 5, and 4. So then my randomly selected people are going to be 7, 5, and 4. So this is just a great way to get random numbers. And it's not really random because your calculator has an algorithm to make it choose the numbers, but it's random enough. So I'm going to take these 3 numbers, 18, 5, and 43. 18 plus 5 plus 43 and divide it by 3. And this is going to give me my first sample. So this X bar is 22.
Melissa, could you show us again how to do the rand part of it?
Okay. I'm going to go over to my actual calculator here.
Okay.
Okay. So when you click on math right here, and then arrow over to prob, because this is probability. This is all the functions of probability that you might need. And then we go down to rand int no repeat. And then just hit enter. So my lower bound, because I have 7 employees, my first, I go 1 to 7. And then I want it to choose 3 values.
Okay, I'm not even getting to there. I get an error.
Okay.
I hit the 8.
Yeah, I'm getting an error too.
So you go down to number 8, and when you hit enter, you get an error. So you go down to 8, and you hit enter and
I
you
get
get
something different every time.
Okay, clear. Okay, let me clear this out. Let me get out of here. Okay, so starting from this screen, are you on this screen right here?
Mm-hmm.
Okay, and then you hit math.
Yes, Matt.
Okay, arrow over to prob. And down to number 8.
Mm-hmm.
Are we there?
Uh-huh.
Okay, then you just hit the enter button.
Okay, I don't get all of that stuff. I just,
This is what I'm getting when I hit enter on number 8.
Okay. Okay, so okay, so your calculator is a little different. I don't know if you have so if you don't get that, then when you set it up like this. So this right here is your lower number. So you'd put whatever your lower number is. So you put 1, and then this one is your upper number. And then this right here is how many you want. So this is your N. This is how many you're choosing. So mine has a setting. I don't know if yours has it or not, but I'm going to show you. If you have it, we'll set it up for you. So your lower value is your first number, then comma, and then the upper value, and then comma, and then how many you're choosing. If yours only goes to 7, you can choose just rand int and not do the no repeat. I think some of the calculators, if they haven't been updated, they might not have the no repeat. I just noticed that I have chats. Hold on a second here. Okay. The calculator online, I know you can get a free trial. I paid for it. It's not that expensive. It's like, I don't know, it was like a year for 20 something dollars or something. It's pretty inexpensive, the online one. Yeah, so you can't use it during a test though. That's the thing. So during a test, you would still have to have a hand calculator, but I do know you can check these out of the library. You can even rent one from the library, but yeah, you can't use the online one for a test. If you have an iPhone, there is an app called Calc 84, or yes, I think it might be Calculate 84. Let me look at it. I don't know what it has for Android. Okay, I just lied. It's let me see here. It's Calculate 84. Where is it? Yeah, Calculate 84. I'm going to write it up at the top here. If you have an iPhone, Calculate 84 is an app that does pretty much everything we do. It looks just like a TI-84. Apple, okay, so Calc 84, both Android and Apple. Thank you. So the thing is technically you're not supposed to use the app on the test, but I'm probably not going to know if you get flagged, you get flagged. But if you're not like searching on your phone and you're just using it for a calculator, I'm probably not going to ding you for that. As long as you're being honest, please just be honest. I'm going to trust y'all. So, but the online one, this mine here is actually the TI-84 Plus. It's actually through Texas Instruments, and it's nice because you can log into it anywhere, and this is what I use. So if you have a TI-84 calculator, if you have the TI-84 Plus, you probably can load this. So click on mode right here. So right next to the second, click on mode. You want down here at the bottom, you want stat diagnostics on. This is going to give you make your calculator a little bit fancier. If you have this, depends on what version of the TI Calc 84 you have. Stats diagnostics should be on and stats wizard should be on. If both of these things are on, it gives you some options that the other ways don't. You could still use it the other way. It's just this is nicer. So if you have this, stats diagnostic on and stats wizard on. So turn both of those things on. And that might give you the special, if you have rand int no repeat, it might give you those little dooley bobbers, those spots to put stuff in. It still didn't.
Yeah, mine didn't either.
Okay. I think it has to do with an update. I don't know. I will do a little research on it. And if I figure it out, I will send an email or post it in discussions or something. I will try to figure out how to get those things. Okay. Otherwise, I'll just show you both ways to put it in with the commas. And otherwise, the rand int no repeat, it's not a super important thing. It just allows you to get random numbers. And it's kind of useful because sometimes we need random numbers. All right. Now
So
that we
after the comma or after the parentheses, what do you do? So parentheses 1, comma 7, comma 3, parentheses.
then hit
Mhm.
enter.
No, I get an error. So
You got an error? Okay, I'm not sure what's going on with the calculator if you're getting an error.
Try just putting a
Yeah, I got-
parentheses, a 1, comma
I got an
7,
error too.
and then parentheses again. It'll give you all 7 numbers, but it'll randomize them, and then you could just pick the first 3.
Okay,
I'm sorry, I didn't catch what she said.
So if you're at the 8 ran intro no repeat,
Uh-huh.
put parentheses, a 1, comma 7, parentheses,
if mine will
and
do
then
that.
enter.
Okay, but hold on. Just hit the wrong thing. I'm gonna
Did you
see.
get random numbers that way?
So what she's saying is, let me put numbers in here real quick, and then I'm gonna do a copy paste and let me paste it. Hold on. Okay, so I'm gonna copy and paste this, and I think this is what you're talking about. So deleting this, delete. I didn't
Yeah,
want
if I don't put the 3 in, then it gave me
Okay.
a 6,
Okay.
1, 5, 3, 7, 2, 4.
to just choose the first 3 then.
Okay,
Yeah.
okay. At least
Uh-oh,
I got
didn't
that.
mean to close out of that. Doggone it. I just closed out of my calculator. I'm gonna need that later. All right. Yeah, it's tough because some calculators have had their operating system updated, some haven't. Different, very small differences in TI-84 calculators have different issues or different things. And it's tough. Okay, so I just totally messed up here. I closed out and didn't stop my, give me a second here. Sheesh. Let's see if I can log in again. I logged myself out and now it's saying you already have an instance of this running. Figures, right? It's all right. Okay, now I'll sign in. I love this online one though, and I just saw that it really wasn't that expensive to buy a year subscription, and just it's helped me a lot. This is the best way for teaching for sure, especially since we're doing this Zoom stuff. Okay, good. I'm all logged in now. All right. So now we can get back to the actual lesson thing here. Now that we played with random numbers a little bit. All right. So I would like each of you on your own, and I will follow behind you quietly, to calculate the mean of these 10, the scores on the tests of these 10 students. So go ahead and just calculate the mean. We're pretending these 10 students are a population. It's not going to matter for your calculations, but it will matter for your notation. Thank you, Holly, for the little tidbit of information there. That was helpful. Right, I'm gonna do this behind you. You got a mean of 79. You did good. We all get there. Okay, good.
So I got 790. Am I just supposed to
Hey,
take the 0 off?
You got to divide by 10 because there are 10 tests here. So you added them all together. You got to divide by 10.
Oh, okay.
So go ahead and just take a simple random sample of 4, and we each just need to do it once. We don't need to do it twice. So everybody take a simple random sample of 4.
It can be any random sample. We don't have to do it on the
You
calculator.
don't have to use your calculator. If you want to use your calculator, go for it. If you don't want to, that's fine as well. Just grab 4 numbers. My X bar was 72.25. Does anybody else have an X bar they'd like to share?
I got 79.25.
Well, yours was really close to the population mean.
Yeah.
I got 81.75.
Wow. Anyone else?
Can you walk me through the sample size? How to calculate that?
Okay, so all you're doing is you're just grabbing 4 random ones. So I could just do 1, 2, 3, 4. Those would be my 4 random. And then just add those 4 together and then just divide by 4. That's all we're doing here. Yeah.
Simple. Okay, thank you.
That's 69.5.
So 69.5. Somebody else said they got 75?
80.75.
80.75.
I got 83.25.
Wow, 83.25. Okay. So notice that none of these are exactly the population. So it's always best if you can use the population to use that because it's clearly more accurate. But if it's a lot of times, if the population is big, you can't poll everybody. Like you're not going to poll the entire voting population and ask them what the shoe size is. I don't know why voting population and shoe size matters, but I might be studying something along with that and say people with larger shoe sizes tend to vote independent. I don't know, I'm making stuff up as I go along. You never know. Somebody might throw money at that. It's people throw money at the weirdest studies. There's so many times I see studies and I'm like, really? Someone paid for that? It's really strange. Okay. Questions about the mean. Are we comfortable calculating the mean? Okay. Let us move on. So median, you've probably heard this term as well. Frequently it's used for like median home prices. We frequently will hear the median home price in Jackson County is this or whatever. So we hear median a lot. This is just the middle of your data. We arrange it in ascending order and it is just the middle number. That's it. And we don't do sample medians. We only do all of the values that we have. So it's just the middle number. So the way we find the median, so this is a whole lot of words for not really a very complicated process. Just letting you know, a ton of words here. Number 1, arrange your data in ascending order. So smallest to largest, just arrange it. I hate it when I have like 30 data values that I have to arrange. Not fun. I'm really bad at arranging data from smallest to largest. Step 2, determine the number of observations.
If you put it in Excel, it will do it for you.
I know, but if I'm doing it, like when I'm doing it by hand for lessons,
Right.
yeah, I'm really bad at it.
And the calculator won't do it for us,
the calculator will calculate the median for you,
but it won't do the ascending.
no, I don't think so.
Okay.
I've not found a way to make it do that, but it's possible. These calculators are fantastic. They do so many things, and every single term I learn something new. So they do a ton of stuff. All right, so determine the number of observations. So how many do we have? And then you figure out which one is the middle. So this is really easy if you have an odd number. There's a number that's clearly the middle, but if it's an even number, it's a little bit, it's still not tricky, but it's, you have to do a little bit of work. So this is our steps for finding the median. And there's a whole lot of words to just say, put them in order, smallest to largest, and find the middle. If I wrote a textbook, it would be like a third of what normal textbooks are, because I'm not going to put so many words in it. All right, moving on. Okay, these are the same employees that we had before. And so I'm going to put them in ascending order, smallest to largest. So I have 5, 18. I usually cross them off as I go so I don't lose things, and I still lose things. 23, 26, 36, and 43. Right, so there are 7 employees here. So the number smack dab in the middle would be this number right here. So I have 3 on either side. So that's the number smack dab in the middle. So that's the median. That's it. It was really just that simple. And what just happened? What happened? I think I just unplugged my iPad. Let me see if I can get it to work again. I'm having like technical difficulties left and right. What the heck? They're gonna make me restart this. Ay, ay, ay. What the heck? It's just, okay, there we go. Yay! Okay. It's not even a Monday. Okay. So just the number in the middle is our median. So now we need to look at what if we have 1 extra? What if I have an odd number? We have a new employee started up. So now we have 8. This new employee travels 70 minutes to work. That's a really long commute. So I'm going to put these in order one more time. So see if I mess up this time. This isn't very many numbers. So if I mess up, then I'm really lacking in caffeine or something. Okay, so once again, they are in ascending order. They're from smallest to largest. But now my middle is right here. Whoops, the whole thing just moved. I don't know if you guys saw that. Whole thing just jumped. What the heck? Okay, from current. Okay, one more time with feeling. I'm going to do this faster. One, 2, 3, 4, 5, 6, 7, 8. All right. My middle is 1, 2, 3, 4 is right here. My middle is in between those 2 numbers. So I can't make this little blue line isn't my middle. There's no median there. So you just take those 2 numbers on either side of it and you just average them. So you just take those 2 and average them. So this is, I don't know why I used my calculator. I could have done that in my head. So my median here is 24.5. So the median doesn't have to be an actual data value. It is just the center of your data. Questions? Now we are going to get into when we use which one, when it makes sense. So that's kind of important. Because, for example, when you are doing, I know I keep mentioning your final project, yet you have no idea what it is. Week 4 or 5, don't even worry about it now, but I kind of, when you're choosing your own, you're going to want to know, when do I choose what? When do I know what to use? And I believe that there's probably questions that say, should I use the mean or the median in this situation? So we'll get to that. Okay. So we have a list of songs. This is their length in seconds. And this is random sample of songs from the 1970s. We're going to look for the median length of songs. I want you to try this. but I'm gonna hope I can put these in order from smallest to largest. I say hope because I'm really bad at this, as I've said. Okay. Any more ones? No, there's a 201. 206. I think I did it. Okay, I put them in order. Go ahead and find your median. So the middle number, thankfully, there's an odd number here. I got 217. How'd we do? All right, good. So that's just the median. There's no symbol for median, and it kind of makes me sad. A lot of times we just do MED. I wish that somebody would come up with a symbol, somebody who's not me would come up with a symbol. I can tell you, I have a group of Algebra 2 kids that would definitely come up with a symbol. They always want to come up with nicknames for things, like always. And I can tell you, like this symbol right here, you know, this plus or minus, you've all seen this in your algebra classes. His name is Steve. My students have named that Steve. So if we answer something and X is like plus or minus 4, my kids will say X equals Steve 4. They've named it Steve and it has stuck. It just is what it is. High school kids are the best. All right, moving on. Okay. So using the test scores, this is an even number. Let's go ahead and find the median here. I would like you to try it on your own. If you need to look up and see what I'm doing, that's fine. I'm going to work quietly. So go ahead and try this one on your own. Maybe you're better at listing things than I am. That's a 90. Okay, so 1, 2, 3, 4, 5. All right, how we do? You got 79.5. You did fantastic. That's what I got. Then again, we can't always trust because there's this whole your math teacher's human thing. I make plenty of mistakes. My sister, this is the thing that you'll learn about me. I tell lots of stories. My sister, she is an artist and she's an amazing artist. She makes money off her art and she's just fantastic. So she told me that every artist has 5,000 bad drawings or paintings in them, 5,000 bad ones. So you need to get all of the bad ones out so that the good ones can shine. So this is what she told me. She told me that she has gotten rid of so many bad paintings. I believe that math is the same thing. We all have 5,000 bad math problems in us, bad math calculations in us. So you got to get all the bad ones out so you can get the good ones. I haven't run out of bad ones yet. So I'm sure you'll get a couple of them in this term because I have not gotten rid of all 5,000 bad ones yet. Even with my whole math degree and everything, I have not gotten rid of them yet. So I'll see some of yours and you'll see some of mine. All right, let's move on. It's me and my stories. Okay, so this is this is important. You might want to flag this page. I believe for sure on our lab next week, on lab 2 next week, you will need, I think it's lab 2, might be lab 3, I can't remember. On one of the labs we do next week, you will have to look at the relationship between the median and mean and determine the skew based on the median and mean. So if we are skewed left, our mean is going to be substantially smaller than the median. So if our mean is smaller than the median, think of this as a number line right here. So my mean is smaller than my median. So therefore it is skewed left. If our mean is larger than our median, so once again, this is like a number line. So if our mean is larger than our median, so further to the right of the median on the number line, or just a bigger number, then we are skewed right. If they're roughly the same, it is symmetric. Now, all of this, notice how all of these are adverbs. We never deal with absolutes. So some of it is a judgment call. But for example, we had 79 for the mean on those test scores and 79.5 for the median. Those are roughly the same. I would say that those that data was symmetric. But if, like, for example, what if I had a 79 for my mean test score and then I had an 85 for the median test score? My mean is significantly smaller than my median, so I would say that was skewed left. So you just got to kind of make a judgment call there. And I believe that anything on the homework or whatever, it will be a significant enough difference that you'd be able to say, yeah, that one's a lot bigger. I'm not going to give you anything that's, you know, one apart and or like just like could go either way. It's going to be, you'll be able to look at it and say, oh yeah, those are close enough. All right. Questions on this? And this is something that's easily forgotten. So keeping this, remembering where this is in your notes is a good idea. Moving on. All right. These are all, are they in numerical order? They're in numerical order. How cool is that? So this data represents the asking price of homes for sale in Lincoln, Nebraska. These are in Lincoln, Nebraska. They are the average or the prices of homes. And I put them in order from smallest to largest because I'm cool like that. And we are going to find the mean and the median and describe the shape of the distribution. I think they're on the next page. Are they? They are. Look at that. So I didn't even make you do anything with it. So because it was a lot of data, I usually won't make you do anything by hand if it's a ton of data, but I'm also going to show you something fancy once we get to standard deviation. So anyway, the mean asking price is 168,320. The median asking price is 148,700. So our mean is significantly higher than our median. So I would say that $20,000 is probably a significant difference. So based on that, we can say that it is skewed right because our mean is significantly higher than our median. Make sense?
I thought the mean was supposed to be a lot smaller and the median was supposed to be higher.
It really depends on what you do. So let's take a look back here. My mean, if my mean is higher, I'm skewed right. Think of this as a number line. The mean is to the right of the median. So the mean is higher. Therefore, it is skewed right.
Oh, because of the number line. Oh,
Right.
okay, that makes sense. The little hill got me.
Yeah, it's not the hill. It's like a number line. So if the mean is to the right on the number line.
Okay.
Yeah, that's
Okay.
it's kind of why I did put the number line thing in there because that's common. People are like, well, this mean is short. I don't know what you're talking about. It's short.
Okay. Yeah.
It's okay. You're not alone. It happens all the time. So because my mean is higher, we have a right skew. Questions? Other questions? That was a good one. I can bet you somebody else was thinking the same thing. So here's what my graph looks like. Oh, so take a look. You can see the skew. You can see that it has that right tail. All right, let's take a look at this one. Mean birth weight, did I find that for you? I'm not gonna make you find this because this is 50 randomly sampled babies. I'm not even gonna make you put this in your calculator, but here are our 50 randomly sampled babies. There's a lot of them, and this is their birth weight in pounds. So take a look. So here on my graph, my mean is right here. It is slightly to the right of my median. My median is right here. I would call these roughly the same. I would say that they are roughly the same. So when my mean and my median are roughly the same, or when I have basically a symmetric graph, that kind of looks cool on there. So it's roughly symmetric and my mean and my median are close to the same. We will choose the mean as the measure that the central tendency that we use. We will use mean for average. Now, if we are skewed, we use median, skewed right or left. But if it is roughly symmetrical, we use mean. The main reason we use mean for that is because there's a whole lot more analysis we can do with a mean than we can do with a median. There's not a ton of math we can do with a median, but there's so much we can do with a mean. So whenever we can choose mean, it's a good idea to do so. But if we have a really skewed data, then we will use the median. And I want to show you later how the median is not as much affected by like extreme values.
So basically, if the median and the mean are far apart in each other, you're always going to use the median.
Yes.
But
Unless
if they're close together, then you use the mean,
perfect, yes.
regardless of the shape or skewed.
Yes,
Which is-
exactly. I love that. I love that. Yes, exactly. Unless you're told otherwise. Like if I tell you to use the mean, then you're going to use the mean. But otherwise, if you're making the choice, if they're very different from each other, choose the median. If they're close together, choose the mean. And a lot of it is just because the mean more represents all the data. Plus there's so much we can do with mean. There's not a lot. The median is not super useful, but the mean is very useful. All right, that was perfect. Okay, moving on. The mode. The mode is the least useful measure of center. The least useful. This just tells you which value occurs the most. What is the most frequent observation? That is all the mode is. And the only time we use the mode is if we want to know which thing occurs the most. That's pretty much it. We don't use it a lot, but it is there. It does exist. So there you go. So we could either have no mode, one mode, or you can have more than one mode. If there's two modes, we call it bimodal. And I just really like the word bimodal. So I thought I'd throw that out there. It's kind of fun to say, bimodal. I'm weird, it's okay. So if it has no mode, that means if none of the observations happen more than once, we say it doesn't have a mode. Oh, that was it. I thought there was another thing. I thought the word bimodal might be written down. It's not a fun word to write, but it's a really fun word to say, bimodal. It's two modes, it's bimodal. I'm sure trimodal is probably also a word, but that's not nearly as fun to say. Okay. I mean, you automatically, if you major in math, you have to be strange. It's just, I think it's on the application. It's there. All right. The data on the next slide represents the vice presidents of the United States. Not all of them, because I know Kamala Harris isn't on there. Can't remember if Mike Pence is on there or not, but it's all of and their places of birth. So here, oh yeah, Mike Pence is on there. Here are all of the vice presidents, except for Kamala Harris, and where they were born. So I'm not going to make you look at this and analyze it because I already did that. Here is my frequency table, and I just put tally marks, and we can see that the one that shows up most is New York. The rest of them, none of them even come close. So our mode here is New York. So nothing else comes close to New York. So that's it. That's how exciting the mode is. I know you all were hoping for some grand excitement, but this is what we got. All righty, moving on up. So this is the, it's a great table that kind of tells you when we use things, what it's for and how we do it. So we use mean when the data are quantitative and the frequency is roughly symmetric. We use median when it's quantitative and that we're skewed left or right. Mode, we only use it when we care about the most frequent observation. So this is a nice little table that you can refer to, and it kind of wraps up our this part of the program. And I'm sorry that this class is going to go a little long because we don't have Thursday, but just trying to make sure that you get the quality lessons. Not the ones on Blackboard that are pre-recorded are not bad. They're just not as current and they're not interactive. They're really not bad. I don't know if any of you have watched them. They're not terrible. It's still just me. You probably don't get as many stories there though. So there's that. All right, moving on. We're now in 3.2. You are somebody who keeps track of that sort of thing. We are currently entering 3.2 land. And we are more than halfway through our slides. So if you keep track of that, that's where we are. All right. Take a drink real quick. You're hanging in there great. Y'all are doing amazing. Okay. So we're going to find other, so all of this ties in really well with the mean, because we're going to learn about standard deviation. We're going to learn about empirical rule. All of that relies on the mean. But first we're going to talk about range. Range is simply the largest data value minus the smallest data value. What is the range of our data? Largest minus smallest. That is it for range. You might have even been able to guess that if I didn't tell you, because that's basically what it is. It's my fault for taking a drink. I swear it's iced tea. Okay, moving on. So we're going to find the range here. So we just take the smallest, the largest, which is 43, and we subtract 5. 38 minutes is the range. So there's 38 minutes between our longest commute and our shortest commute. Really, that's it. No more exciting than that. Questions? All right. Okay, standard deviation. I'm only going to require you to calculate standard deviation by hand one time, maybe twice in this lesson, and then your written homework. Your handwritten homework will require you to calculate the population standard deviation once and the sample standard deviation one time. After that, you will never again have to calculate it by hand. I will show you fancy schmancy calculator functions. And yes, Excel can do it also. So the standard deviation tells us how spread out the numbers are. So the larger the standard deviation, the more spread out they are. The smaller the standard deviation, the less spread out they are. This is our lowercase sigma right here. I am the worst sigma drawer that ever drew a sigma, but you will get used to it. This is for the population standard deviation. So don't worry about memorizing this formula. You will use it a couple of times, but then you will just use your calculator function. So basically what this is saying is you take each data value, you subtract the mean from it, and then you square it. So here, take a data value, subtract the mean from it, and then square what you get. Do that again right here. Take the next data value, subtract the mean from it, and square it. You do that with all your data values and you add them all together. Then you divide by the number of data values you have, then take the square root. This is for the population standard deviation. Sample has a different formula, just slightly different. This is for population. And we're going to do one together. All right. So let's do this with our travel times that we use to find the range. I'm gonna walk you through it. So I highly recommend writing it down and doing this along with me. It's gonna connect what you're doing to your brain and your memory. First thing, find the population mean. Does anybody remember the mean of the travel times? Because I forgot it. Does anyone tell me what that is real quick? The original travel times? Or I could calculate it again.
Wasn't it 24.5?
Sounds right. Do we agree with that? Even if it's not, we're gonna call it that. I think it was
24.9, or, okay, yeah.
was 24.5.
You want 7 or 8 employees?
It was the 7 employees. It was
Okay.
the mean, not the median.
Okay, 24.9.
24.9, okay. Okay, so my mu is 24.9, okay. So the next thing we're gonna do is we're gonna subtract the mean from each number and then square the results. So I'm gonna do 23 minus 24.9, and then I'm going to square it. So that is 3.61, then 36 minus 24.9 squared. This is 123.21. At least this one right here, I don't have to put in my calculator because it is the same thing. And 5 minus 24.9 squared. And then 26. Whoa, did something weird. Okay. All right. So I just took each value, subtracted the mean, and then squared it. Give y'all a minute to catch up. Okay. The next step is you add the squared results and then divide by the number of values. I'm just going to add all of those results together.
How are there, I didn't do the math with you, but how come some are like 396.01 and then others are 3.61?
It's because of the difference between them. So think about what the difference between 5 and 24.9 are. That's a huge difference. It's almost 20. And so once you square it, it gets big fast. And so there's less than 2 difference between 23 and 24.9. It was just because you're squaring it, the numbers get big fast.
Okay.
Uh-oh, I don't know what I did, but something weird happened. Oh, okay, I see. Somehow I ended up with a weird negative sign in there instead of a decimal. We're going to fix that. There we go. So I have 902.87 and I'm going to divide it by 7. I think I'm going to add them together again because I don't trust myself. Calculator typos are the most common error. Yep, okay, I got the same thing. So here I have this right here is I have 128.98. Make sure that we each got there. Okay, so the final thing. To take the square root of what you got. So my sigma is 11.36 approximately. Nobody's going to mark you down for not putting the approximately squiggles, but I might mark myself down. So what this basically is telling me is that the average distance each of those values is from the mean is about 11.36. That's the average distance of each value is from the mean. So that's what the standard deviation is basically telling us. We're going to be using it for we're going to be using it a lot. But right now that's enough of an explanation of what it is the average distance things are from the mean. The reason we do the whole squaring thing and then square root it later is because we want to get rid of the negatives. That's kind of the point of the squaring. And it just turned into this big, huge formula. And you'll be really happy when you get to just put it in your calculator and call it good.
But how did you get the 11.36?
I took the square root of 128.98.
Okay.
Yeah. That gave me the 11.36. Did that get you all there? So this right here, if you are doing it by hand, it's really good to keep these steps handy because this is how you, and this is just like really simply how you do it. So do we want to try one more by hand or do we want to go straight to the calculator function? I'm cool either way.
Should we do the ones in the handout?
If we wanted,
together?
we want to do this one. Y'all want to,
The one that's in the hand and homework.
I'm not going to do that one with you, but, but I will do this one with you. Nice try though. But I'll
How
do
will
this.
we know which is it number 5 that's gonna need us to do this?
So it says to do the one that says calculate the population standard deviation.
Find the population or standard deviation for the following set of data.
Yep.
And so we
It
do that for the sample and the population?
Yeah, we haven't done sample yet.
Okay,
So we haven't done sample yet. We've only done population. Do you guys want to get to one where we need to do the sample? So we'll just do that one by hand? Or do you want to do another population first? Either way is fine. They're really close to the same thing. They're just one slight difference.
Can we do another one?
Okay, so this one
Yeah.
sets it up nice because it kind of has part of the math there for you. So our mean here was 79, right? It was exactly 79. Okay, so we would do 82 minus 79. And then I'm just going to square it and put the answer in the next box. I'm going to put the square here. 82 minus 79, and then I'm going to square it. Oh, that didn't work. Yes, it did. Okay, this is 9.
It
So-
was 79.5.
Where'd you get 79?
Wasn't that our mean? I
I
swear.
think it was 79.5.
Okay, I thought 79.5 was the median. I'm gonna check though.
Oh,
Oh,
yeah.
you're right.
Oh, yeah. I think you're right.
79 for the mean.
Right, and mean is what we use here.
Okay.
Sorry.
No, it's fine. I'm
You were
glad
testing us.
you gotta check me. You gotta check me. I'm 100% okay with that. You are never going to offend me by checking my math. Once you get all of those values, add them together. Then you take those values that are added together and you're going to divide by the total number of values we have. Okay, divide by n, which is number of values. You're always going to use n for like either number of values or sample size or whatever. N is always used for that.
Can you explain the difference between the capital N and the lowercase n?
So capital N is the size of your population. Lowercase n is sample size.
Okay.
I won't mark you down either way with using the wrong n. I feel like things like that are kind of trivial and in the grand scheme of things don't matter a whole lot. So I'm not going to ever mark you down for that, but you will see it in notation. So that was a good question. So after you take your added together, your sum, and divide it by the samples or the this population here, then we're going to take the square root of that. So this right here is my standard deviation.
So when we're calculating the standard deviation, are we essentially just calculating the mean of the outlier to the mean?
I mean, you're basically just finding the average distance every value is from the mean.
Uh-huh.
Basically what you're doing. But
Cool.
we had to square everything. So after we are done with everything, then we unsquare it by taking the square root. So at the very end, that's what the square root does, is it gets rid of all of these squares that we have here. So, but don't square root too early, otherwise it makes it wonky. And it was some person smarter than me that said square rooted at the end, so I just believe them. But that's basically, it's the average distance every value is from the mean. So the larger our standard deviation, it's saying that that average distance is pretty big, which means my data is more spread out. So if that average distance is small, that means my data is not quite as spread out because that average length is small or average distance is small. That makes sense?
Yeah, thank you.
You're welcome. Whenever
When-
I provide that, I will. Yes.
When I square 96.4, I get 9292.96.
Okay, so you squared it rather than square root. So hit
Oh,
second x squared and then put that number in. So the above the x squared is the little square root.
oh, got it.
Okay, perfect. Are we feeling a little bit better here? Okay, let's go to sample standard deviation, and then we will then I'll show you fancy calculator stuff. Sample standard deviation, there's one difference. Well, two differences actually, because s, lowercase s, is the symbol for sample standard deviation. We just use a lowercase s. And the only other difference is we divide by n-1 instead. And the reason we do that, so remember way back when, all the way back 20 minutes ago, when we were calculating all of those sample means and how different they all were, because there's so much variation in samples, we need to kind of err on the side of caution. And we need to have a little bit larger standard deviation to kind of make up for that variation. So we divide by 1 less than the sample size. Don't worry about the degrees of freedom. Probably in chapter 9, I will be explaining all about what degrees of freedom are. So don't even worry about what this means right here. Don't worry about this. I can't even circle it. It is called degrees of freedom, but don't even worry about it. But do this standard deviation exactly the same way, but divide by n minus 1 because it's a sample. So otherwise, all of the other math is the same. Okay, let's move on. So here we have a teeny tiny little small sample, and we're just going to do the sample standard deviation 1 time because it's so much the same. So this is my 1 tiny little sample, and we're just going to do that math. So we need to find the mean of this first. So I'm just going to add those together and divide by 3. So my X bar, which is for a sample, is about 22.3. So this is the mean we are going to use for our standard deviation. So I'm going to do 5 minus 22.3 squared plus 5, or whoops, that should be 26. 26 minus 22.3 squared plus 26 minus 26. What the heck is wrong with me? 36 minus 22.3 squared. If you're comfortable with your calculator, you could put all of this in your calculator at one time. If you need to do it piece by piece, that's fine. Go ahead and do that. But if you're confident with that calculator, just make sure you're using parentheses. You can put it in your calculator exactly how it is, exactly how it's written right there, even though I did something wonky. That sounds like something I would do. There we go. I got 500.67. All right, now we take that 500.67 and we divide it by n minus 1. My sample size is 3, so n equals 3. So n minus 1 is 2.
Sorry, can you explain that one more time?
So because my sample size is 3, and this is a sample standard deviation, we divide by 1 less than our sample size.
Gotcha.
I'm going to divide by 2. So we still have that one last step. And now final thing you do is you take the square root of that answer. So I have approximately 15.82. So my sample standard deviation, so I'm going to say S, is approximately 15.82.
So how far out would we go past the decimal? How many digits?
It really depends on what my open math says. For some reason in my brain, if my mean is 1 more than my my numbers and my data are, I'll go 2 more. I'll go to 2 decimal places for my standard deviation. That's just me though. I would just go with whatever my open math tells you to do. I usually just go to 2 decimal places for standard deviation and 1 decimal place for mean. But it all depends on whatever my open math tells you to do. They will tell you what to round to pretty much every time. I will warn you though, occasionally, because it's a free program, there are some glitches. Sometimes they will tell you to round to 2. And if you get it wrong, you try rounding it to 4 if you're pretty confident, because every once in a while there's a glitch and they really want 4 when they say 2. But this whole thing about this free program. The program that they used to use was $100 a term. So I am willing to have a glitch or 2 here or there in order for it to be free. I hope you guys feel the same way. So just try rounding it to something different. If you're pretty confident with your math, just try doing that again. Try something different. All right, I think. Okay, go ahead. No, go ahead.
I was gonna ask you to explain the 2 again, because I'm still confused.
Okay, so I'm going to go back to this. So when our original standard deviation had us dividing by n here, but
Uh-huh.
this we divide by n minus 1. N is your sample size. So whatever size your sample is, you divide by 1 less than that. So your sample size minus 1. So going back here, my sample size is 3. N equals 3. So therefore, n minus 1 equals 2. And this is what I divided by. So if I had a sample size of 6, I would divide by 5. You divide by 1 less than your sample size.
Five minus 1 would be, I'm
I said
sorry.
I said if I had a sample size of 6, you would divide.
6, okay. Okay,
Yes, just whatever your sample size is, divide by 1 less than that. Does that help? Are we?
yeah,
Okay, good.
thank you.
We're going to do fancy schmancy calculator stuff now. I'm going to use, what data am I going to use? Let's use this data here. We're going to use this data for our fancy schmancy calculator stuff, and we're going to see how close we get to the same numbers. It's going to be slightly different. So get your fancy schmancy calculator out. The first thing we are going to do is enter our data. So if you click on this button right here that says stat, I'm going to try to get a little bit closer. Please let me get a little bit closer. Okay, whoop, I went too close. Okay, so click on this button right here that says stat, and we want the first option, which is edit. You're going to have these lovely, you may or may not have stuff in your columns here. I have stuff in my columns. I'm going to show you how to clear it out. So everybody get to this screen, hit stat, and then you want edit. So if you have stuff in your columns, you're going to arrow up so that L1 is highlighted, which is list 1. And you're going to hit the clear button and then enter, and it will clear your column. Do not hit delete. Hit clear and then enter. You are clearing the column. You are not deleting it. You are clearing it. So I'm going to go over, arrow over to, I just arrowed over to L2, go up arrow until L2 is highlighted. Then I'm going to hit clear, enter, and that deletes everything, clears everything in the column. So that's how you clear that out. Now I'm just going to enter my numbers. So in this data that we have here from the travel times, it's going to put in 23, enter, 36, enter. I'm just going to do that with all the numbers. Just putting the number in and then hitting enter. It'll advance it by itself. 26, enter, 43, enter. And then all of my values are listed in here. I'll give you a second to get yours in there. This is the travel time data.
If I don't know if it matters for this, but if I put a wrong number in the wrong place,
You can just
like-
highlight it back up, go back up, like say this was supposed to be 24. You just
Mhm.
scroll up till it's highlighted, and then you can put 24 in, just overwrite it.
Oh, okay.
Okay, does everybody have their numbers in there? Okay, now we're gonna hit the stat button again. You're gonna arrow over to calc right here. So arrow till calc is highlighted. We want this first one right here. It's one var stats, one variable statistics. This is what we're looking for. Now I'm going to hit enter, and your list right here should say L1. If it does not, I'm going to show you how to put it in there. Notice over the number 1 right here. I don't know if I can notice how over the 1 right here in blue, it says L1 right there. If you hit second one, it will populate L1 into your list. If all my stuff was in L2, I would do it on the 2. I'd do second 2, and it would put list 2 in there. Whichever list you put your stuff in, you'll put L1 right there. I don't want anything in frequency lists, so I'm going to just delete that. I'm going to clear that out. So it should just be L1. There should be nothing in this frequency list. Arrow down to calculate and hit enter. And you're going to have all this crazy stuff here. Does anybody need me to walk through that again? One more time. So it's stat, arrow over to calc. Oops, one var stats, which is one variable statistics. The list L1, do second. The number 1 will give you your L1. Clear out your frequency list, go to calculate and hit enter. Okay, so X bar, that is the mean. Our TI-84 automatically decides that it is a sample just because that's what TI-84 does. But if you know it's a population, remember population and sample mean calculated exactly the same way. So our mean was 24.9. This is 24.9. It's the same thing we had. This right here, whoops, I didn't mean to do that. The second thing is sigma X. This is just everything added together. If you, for some reason, needed all your data values added together, that's what that is. I have never used the third one. This is the adding all of the values squared, all the squares of the values together. I've never used that for anything. SX, this is something you might want to write down. SX is your sample standard deviation. Sample standard deviation is SX. Sigma X is your population standard deviation. Sigma X is the population standard deviation. I don't remember what we got. I'm going to look it up. I'm going to moving on up.
I had 11.358.
Okay, so basically they just don't round any mid calculations. So it's basically the same thing, right? So you would round it to 11.36 on both of them. So it's perfect. And sigma X, or we didn't do a sample, so I don't know about that. Something else, so that I will explain all of the rest of the numbers later, but it tells me N is 7. That's how many data values I had. Down, you scroll down, you can get your median. Median is 23. Now, if you have a small number of data values, it's not going to make sense to put them all in your calculator for the median. But if I had 30 values and I didn't want to put them in order, this is nice. If I don't want to put them in order, this is nice that it does it. At least will find my median for me. I will talk about what the rest of the stuff means later on. But right now, your mean, your sample standard deviation, and your population standard deviation, that's really cool. That's so much quicker. Questions on the calculator? All right, I'm going to move on to, I'm going to get back to the other screen. I don't care about the histogram. We're going to real quick talk about comparing standard deviations, and then we're going to move on to empirical rule. We probably have about 15 minutes left, just kind of giving you an estimate. So thank you all for bearing with me. So taking a look at the standard deviations for McDonald's and Wendy's, take a look at their wait times. So you're going to go to McDonald's or Wendy's, and these are wait times at McDonald's and Wendy's. So these times really mean nothing other than, hey, look, we've had a couple of long waits here at McDonald's, and there are a couple of no waits at all. And right now, this raw data doesn't really mean a whole lot to us. But once we find the standard deviation, it's going to help us just a little bit. So my standard deviation for Wendy's is 0.738, and this is a sample because clearly that was not the entire population of orders at Wendy's. My standard deviation at McDonald's was 1.265. So the reason for comparing these is I'm going to make a decision. I need to run somewhere for lunch, and I need to make sure that that I can get in and out quickly. And I know that I usually get in and out quickly at both of these places, but this tells you which one is more dependable. So Wendy's standard deviation is smaller, which means that all of its values are less spread out. So it's more dependable. I can count on it's probably going to be really close to the same wait time at Wendy's, no matter when I go. McDonald's is a little bit bigger standard deviation, so it's not quite as dependable. The average distance away from the mean is it's like 1.25 minutes, where it's less than a minute for Wendy's. So if I'm really caring about dependability, I would go to Wendy's. Does that kind of make sense? Okay. All righty then. All right. Variance, basically, this is all you get about variance. I have never found a use for variance, but my open math asks you for it. All variance is it's the standard deviation before you take the square root, or it's the square of the standard deviation. That's all variance is. I'm sure that somewhere out there's a use for variance. I haven't found one, but you will be asked for it in my open math. You will not be asked for it in any test, but my open math will ask you the variance. So just square your standard deviation and then move on with your life. All right. Let's talk about the empirical rule. I love the empirical rule. So we're going to be drawing a picture. You will draw this picture 3,482 times this term. Obviously, that's an estimate, but you will draw this picture a lot, and it will become extremely useful to you. So, but we're going to go through all of the words because it's a textbook. So it's roughly bell-shaped. If we have a roughly bell-shaped distribution, then about 68% of our data is going to be within one standard deviation of the mean. So that means one standard deviation above the mean and one standard deviation below the mean. So if I take my mu and I add a standard deviation, then I take my mu and subtract a standard deviation, 68% of my data will be between those two values. And I'm going to show you a pretty picture and everything in a minute. About 95% of your data is within two standard deviations of the mean. So that means if I add 2 times the standard deviation to the mean, and I subtract 2 standard deviations from the mean, between those two values will be 95% of my data. And this is also where all the usual values are. Anything more than 2 standard deviations away from the mean is an outlier. And we'll get more into that next week, but just somewhere in your brain, just store that information away. Anything more than 2 standard deviations from the mean is an outlier. So just keep that in your brain. However, we do have one more here. Oh, wait. We can use the empirical rule based on sample data, but we just put X bar instead of mu and S instead of sigma. Just FYI. So here's the picture that you will be drawing 3,284 times. So this shows you one standard deviation away from the mean. We have 68% of our data. I believe in your homework, the 3.2 homework, this will become super useful. If you printed out the PowerPoint, this is a really great place to sit and add things together, because it's going to ask you what percent of your data is in between these two places. And you'll just add all of these up or whatever in order to get that percent. So if you go to the tutoring center, they will not automatically refer to the empirical rule. They'll go to the fancy calculator functions that we use later in the term. My Open Math wants the approximations, not the exact values you get from your calculator. Just letting you know. If they try to get you to do something called normal CDF in your calculator, do not do it. Make sure you let them know you need to use the empirical rule instead, because they try to get you to do fancy stuff from later on, and it's not going to help you here. Just, that's my disclaimer. So this shows you 99%, 99.7% of my data is within 3 standard deviations of the mean. But all of my, so anything outside of here though, anything out here, that would be outliers, anything more than 2 standard deviations away. But this is the lovely diagram. We love this diagram. I draw it so frequently. All right, let's move on. Okay, we're going to use the empirical rule here. So the following data represents the serum HDL cholesterol of 54 female patients of a family doctor. So this is a sample of 54 female patients. And I'm not going to calculate the mean and standard deviation. Thankfully, I've already done that. So we're going to, so here is my mean and standard deviation. Uh-oh, this should say mu. Mu equals or X bar. And then sigma equals. Okay, sorry about that. Sometimes I lose things. So my mean is 57.4 and my sigma is 11.7. This is my lovely histogram of the thing. And you can see that this is approximately normal. There might be a slight right skew, but I don't think it's enough to say it's not normal. Most of the time you're going to be told it is approximately normal, and then you can just move on and use your empirical rule. So let's take a look. I already did that. So here is my whatchamacallit, my empirical rule, my bell curve. These are the values. So this was the mean that we calculated. This was my mu. What was my standard deviation? What was that? Okay, 11.7. Okay, so I took the mu, I took 57.4 and I added, I forgot it already, it was 11.7, 11.7, and I got 69.1. That right there, this right here is 1 standard deviation above the mean. So this is mu plus 1 times the standard deviation. That's how I got that next value. I took 57.4 and I subtracted 11.7 to get 45.7. This right here is that value. So this is mu minus 11.7 or one standard deviation. That's what that is. Then I subtracted 11.7 again to get 2 standard deviations, subtracted again to get 3 standard deviations. Same thing above, add 11.7 to 69.1 to get 2 standard deviations, add it again to get 3. The only reason I'm going into such detail about the math is because frequently, if we don't hear it, it's not going to stick in there. You're going to get to your homework. And even sometimes during a lesson, you think, oh yeah, I've got this. But as soon as you get to your homework, you're like, I don't got it. I know none of you have ever experienced that before, ever. No. Okay. We want to know what percentage of all patients have serum HDL between 34 and 69.1, according to the empirical rule. So here I am. 34 is right here. So I want this slice. I want this slice. And I want this slice. So what I'm going to do is I'm going to add those percents together. 13.5 plus 34 plus 34. And just, where's my calculator? Going to add this together. I probably could do this in my head, but I don't really trust myself. So this is 81.5. So I can say about 81.5% of all patients are between 34 and 69.1 of the serum HDL. This is basically how you're going to do your homework with the empirical rule. Draw this bell curve, refer to it so that you can just add those percents together. And do not forget this and this. That's the most forgotten thing is those little 0.15% in the tails. Don't lose those. They may be little baby numbers, but it'll mess you up. I'm not gonna go back. It wants me to go back and count them all and figure out the actual percent. So it was close. It was really close to that 85%. We're not gonna do that, but it was really close. And so basically, the actual percents also, if we put them in the calculator with a fancy function, would be slightly different. But I don't think anybody's going to be upset if it goes from 81.5 to like 80.03 or something. It's close enough because we don't deal in absolutes. That's it. That's my last slide. Look at that. I got done about 5 minutes earlier than I expected. So questions on this? These are, remember, you're still being recorded, but if you have questions that'll help others, now's the time to ask those.
I don't know what the 0.15% is for.
That's for, because, let me go back. This good question. Let me go back to my original here. So take a look, 99.7% of all my data is within 3 standard deviations of the mean. So what's left are these little babies right here. After 99.7, so 100% minus 99.7 is 0.3%. And I have to divide that in 2 for my little baby ends. Did that help? Okay, good. That was a great question. Any other questions? That was perfect. So this, get used to drawing this. If you can remember these numbers and you'll get good at drawing this, it's going to help you so much. It'll really help you on the test. I'll help you on your homework. We're going to keep drawing it all the way through the end of the term. It's super useful. I still draw it all the time to find numbers. Then again, I mean, I do teach stats here in the high school, but still, I draw it all the time. All right, I'm going to stop the recording then. And then if anybody has any non-recording